Assalamualaikum and hi, we are from Group 6 of EH1105C and we are going to start our presentation on the topic assigned to us, which is the industrial methanol synthesis and application. So, let's get started. I am Nur Izzatullah Muhammad Ahmad and now I am going to explain on the background information of methanol. First, methanol is a polar substance which means it is soluble in water. Next, methanol is a colorless liquid which boils at 64.96 degrees Celsius and it is solidified at negative 93.9 degrees Celsius. Methanol also forms explosive mixture with air and is burned with non-luminous flame. The major uses of methanol, it is used as a solvent or an intermediate in industrial sector. Other than that, it is also used in the energy sector. Last but not least, methanol is produced from syngas which is obtained from the steam reforming of natural gas. So now, I am going to share on the timeline of history in the methanol production. Firstly, it is used by the ancient Egyptians in the embalming process where they obtained the methanol from the pyrolysis of wood. Next, in 1661, Robert Boyle produced pure methanol through further distillation. John Baptist Dumas and Adrian Pilligard determined the composition of methanol in 1834. In 1905, Paul Sabatier and John Baptist Sanderon discovered that copper effectively catalyzed the decomposition of methanol. In 1921, George Patet patented the basis of a high-pressure catalytic process for the methanol synthesis. Methanol production is started with the catalytic process developed at Bedices, aniline and soda-pervic, which is now known as PAS, back in the lunar site of Germany in 1923. In 1966, Imperial Chemical Industry, or known as ICI, constructed and commissioned the first LPM plant in Billingham, UK. That's all. Thank you.
Now we are going to look at the reaction of methanol from syngas. The main reaction from the methanol from syngas is carbon monoxide plus 2 mole of hydrogen produce methanol with a heat around negative 19.8 kJ per mole, while the other reaction is carbon dioxide plus 3 mole of hydrogen produce methanol and water with a heat around negative 49.6 kJ per mole. The temperature while this reaction occurs is 250 till 300 degrees Celsius and the pressure is around 50 to 150 bar, which is equal to 5 to 50 megapascal respectively. The catalyst used while this reaction happens is zinc oxide or chromium trioxide was used as the catalyst in the early days, but for now, coprom is widely used in the industrial. The byproduct from the reaction is methane, methylformate, high alcohols, and acetone.
Okay, for the equipment, there are three processes that use different types of equipment to produce methanol. Okay, for the first process is the ICI process. An adiabatic reactor is used with a single catalyst bed. For the second one is the Lurgi process. For this process, a cooled tubular reactor is used. And the last one is the Haldor-Topsøe process. Several adiabatic reactors that have been arranged in series are used. For the production process, methanol is produced from synthesis gas or syngas, which has carbon monoxide and hydrogen gas as its main component. Most syngas for methanol production is produced by steam reforming of natural gas. Next step is the catalytic synthesis of methanol from the synthesis gas. Unlike the reforming process, the synthesis of methanol is highly isotonic, taking place over a catalyst bed at moderate temperatures. If an external source of carbon dioxide is available, the excess hydrogen can be consumed and converted to additional methanol. The most favorable gasification process are when the excess hydrogen is burned to water, which steam reforming is accomplished through the partial oxidation reaction. Conventional steam reforming is the simplest and most widely practiced route to synthesis gas production. The carbon dioxide and hydrogen produced would react with additional hydrogen from the top set of reactions to produce additional methanol. Crude methanol is distilled to separate methanol from water and impurities. To achieve a reasonable conversion to methanol, plants must operate at high pressure.
Assalamualaikum. I'm going to continue on the applications of methanol. So the first one, it is applied as feedstock to produce chemicals such as acetic acid and formaldehyde, which then used in making products such as acrylic plastic, synthetic fibers, which used in making clothes, plywood, used in making in constructions, and then chemical agents producing pharmaceuticals products, adhesive as well as paint. Next, it is applied in energy-related sector, which is, for example, automotive. So the methanol as fuel make cars more energy efficient, and also the clean burning fuel helps improve the air quality by reducing harmful gases emission, for example, carbon monoxide and nitrogen oxide. So this high octane methanol and clean burning fuel can be an important substitute for gasoline in the automotive vehicles. Next is in power generation industries, which is it acts as a backup in emergency situations, for example, after disaster. And then it is also used as a main fuel source for sites beyond the reach of power grids, for example, in a small islands. So these can help to keep homes bright and also businesses working. Last but not least is the thermal application, which is the industrial boilers replacing the coal-fired boilers. So these industrial boilers can contribute to local air quality benefits. So these endless applications have made methanol as an essential ingredient as well as innovative clean burning alternative energy solution in our daily lives. So that's all from me. Thank you.
Next is the diagram of methanol production process. So this figure 1 shows the flow scheme of the ICI low pressure methanol process. In this process, an adiabatic reactor is used with a single catalyst bed where the reaction is quenched by adding a cool reactant gas at different height in catalyst bed, where the temperature in the bed has a sawtooth profile. Next, figure 2 shows the schematic of Lurgi reactor for methanol production. This process is similar to ICI process except for the reactor type. In this process, a cool tubular reactor is used, where the catalyst particles are located in the tubes and cooling takes place by boiler feed water. The Lurgi reactor is isothermal process. And lastly, figure 3 shows the flow scheme of the reaction section of the Halder Topsy methanol process. So in this process, several adiabatic reactors are used where the intermediate cooler remove the heat of reaction and the syngas flow radially throughout the catalyst bed to reduce pressure drop compared to axial flow. And the crude methanol purification are similar to other process. Next is the example of methanol production. So there are three. Firstly, the Pengarang Refining Company Senia Berhad. It is located at Pengarang, Johor. Secondly, the Petronas Chemicals Methanol Senia Berhad. It is located at Labuang. And lastly, BASF Petronas Chemical Sandiang Berhad, where the location is at Gebeng, Pahang. That's all from our group presentation. Thank you.